Welcome to Sci Discovery Chronicles. Today, we're diving into a mind-bending topic that holds the potential to revolutionize the way we power our world: superconductors. Imagine a world where energy flows effortlessly with no loss to heat, friction, or resistance. A world where the efficiency of electrical systems is maximized beyond our wildest dreams, making everything from our electronic devices to our transportation systems operate with unparalleled effectiveness. Well, that future may be closer than you think, thanks to superconductors. But what exactly are they? How do they work? And what potential do they hold to shape the future of technology and energy? In this video, we're going to explore the fascinating world of superconductors, materials that can conduct electricity with zero resistance. Yes, zero resistance. That means no energy loss, no overheating, and no wasted power. Stick with us as we unravel the complex yet intriguing physics behind superconductors and how they could be the key to unlocking limitless energy. The basics of electrical resistance. Before we can understand superconductors, we need to talk about something fundamental: resistance. In everyday electrical systems, resistance is the force that opposes the flow of electric current. Think of resistance like friction in the mechanical world. Just like friction makes it harder to push a heavy object across the floor, electrical resistance makes it harder for electricity to flow through a wire. This resistance generates heat, just like the heat you feel when charging your phone or using your laptop for too long. This is why electrical components can get warm and why energy is wasted. Most conductors, like copper or aluminum, have some level of resistance, which means they lose some of the electrical energy as heat. But now, imagine a world where you could eliminate that resistance completely. No more energy loss. All the electricity that goes in comes out on the other side, perfectly preserved. That's where superconductors come into play. What are superconductors? Superconductors are materials that, when cooled to extremely low temperatures, enter a state where they have absolutely zero electrical resistance. This was first discovered in 1911 by a Dutch physicist named Heike Kamerlingh-Onnes, who noticed that mercury, when cooled near absolute zero, could conduct electricity with no resistance at all. This discovery was groundbreaking. But why does this happen? It turns out that under certain conditions, the electrons in a superconductor form pairs known as Cooper pairs that move through the material without colliding with atoms. In regular conductors, electrons scatter when they hit impurities or atoms, which generates resistance. But in superconductors, these Cooper pairs glide through the material effortlessly, creating a perfect flow of electricity. This unique property opens up a world of possibilities. Without resistance, energy transmission becomes highly efficient. In theory, you could transmit electricity over vast distances without losing any power along the way. No wasted energy, no heat buildup. It's a clean, perfect system. But there's a catch. Most superconductors only work at extremely cold temperatures, often requiring cooling with liquid helium or nitrogen to reach their superconducting state. Types of superconductors and their applications. There are two main types of superconductors: low-temperature and high-temperature superconductors. Low-temperature superconductors, like mercury or lead, need to be cooled near absolute zero to work. But in 1986, scientists discovered a new class of superconductors known as high-temperature superconductors, which could operate at relatively higher temperatures around minus to 100 degrees Celsius, still cold, but not as extreme. These high-temperature superconductors have generated enormous interest because they make the idea of real-world applications much more feasible. While low-temperature superconductors are used in niche applications such as MRI machines and particle accelerators, high-temperature superconductors could lead to innovations like highly efficient power grids, maglev trains, and even quantum computers. Let's break down some of these potential applications. 1. Power grids. In today's power grids, a significant amount of electricity is lost during transmission, mainly due to resistance in the wires. Superconducting cables could drastically reduce or even eliminate this energy loss. Imagine a world where electricity flows from power plants to homes and businesses with perfect efficiency, reducing costs and lowering carbon emissions. 2. Magnetic levitation maglev trains. Superconductors also have the fascinating ability to create strong magnetic fields. This is the basis for maglev trains, which use superconducting magnets to levitate above the tracks, eliminating friction and allowing them to travel at incredibly high speeds. Some maglev trains are already in operation, but widespread adoption could revolutionize public transportation. 3. Quantum computing. Perhaps the most exciting frontier is in the field of quantum computing. Superconductors can be used to create quantum bits or qubits, which form the foundation of quantum computers. These computers have the potential to solve problems that are impossible for even the fastest classical computers to tackle, opening up new possibilities in fields like cryptography, materials science, and artificial intelligence. Challenges in superconductor technology. While the potential of superconductors is incredibly exciting, there are still significant challenges to overcome before we can fully harness their power. The most obvious challenge is the temperature issue. High-temperature superconductors still require cooling to extremely low temperatures, which can be costly and energy-intensive. Researchers are actively searching for materials that can become superconductors at room temperature, which would be a game changer. There are also challenges in manufacturing and maintaining superconducting materials. Superconductors can be delicate and require precise conditions to maintain their superconducting state. Scaling up production to the levels needed for widespread use in power grids or transportation systems is another hurdle that scientists and engineers are working to overcome. The future of superconductors. Despite these challenges, the future of superconductors looks bright. Advances in materials science, particularly with the discovery of new high-temperature superconductors, bring us closer to a future where these materials could become a part of everyday life. Imagine a world where our power grids are lossless, where high-speed maglev trains are the norm, and where quantum computers solve the world's most complex problems. The journey from discovery to widespread application has been slow, but progress is being made every day. New research is pushing the boundaries of what we thought possible, and the dream of room-temperature superconductors may not be as far off as we once believed. Superconductors have the potential to unlock limitless energy, revolutionizing the way we live and power our world. From efficient energy transmission to futuristic transportation and quantum computing, the possibilities are endless. The road ahead may still be long, but with each new discovery, we get one step closer to a world powered by the incredible physics of superconductors. If you found this video fascinating, don't forget to like, share, and subscribe to Sci Discovery Chronicles for more deep dives into the amazing world of science and technology. Together, let's explore the mysteries of our universe.